Hey, welcome everyone to this AMR training hackathon that we've been put together with MRC Claims Big Data cloud platform and infrastructure, as well as JPIAMR, this joint program initiative for AMR, which both of which are going to be introduced specifically, and then PHAGE, which is the Public Health Alliance for Genomic Epidemiology. Today we're going to do kind of a focus on three speakers and myself, and then a quick panel discussion. Going to focus on kind of just the basics of databases, resources, and tools for antimicrobial research. And I'll introduce each person as we go. But first, Kara Sang is going to talk about database and resource for AMR genomics. Mike Feldgarden is going to talk about overview of AMR gene prediction tools. Inez Mendez is going to talk about some of the harmonization and PHAGE stuff, how to standardize AMR results and report them. And I'm going to give a very quick demo of the things they've talked about on what you would actually run on the command line to do so. And then we're going to wrap all up with a panel discussion about, various questions and things people have about that have come up from the day. So the small bits of housekeeping first is you're welcome to ask questions throughout. You'll see there's a Q&A kind of panel. So any questions you have, and you can ask anonymously if you're anxious or nervous and don't want to reveal your name, you can ask questions through there. And then if someone else asks a question that interests you, you can vote it up. And we'll try and address them, some of them at the end of each talks, but then probably cover a lot of them in that panel discussion at the end. So first, let's introduce all the different bodies that have been involved and et cetera. And we'll start with Emma Griffiths to introduce PHAGE and what PHAGE is.
Great, thanks. Thanks for that, Finn. I'll just share my screen. Can you all see this? See the slide here? I'll take that as a yes. Okay, so
Okay, yes.
Great. Okay, thanks. So hello, everyone. It's so great to see all of the different participants today. Good morning, good afternoon, good evening, wherever you are. My name's Emma Griffiths. I'm from Simon Fraser University in Vancouver, Canada, and I'm the chair of the Data Structures Work Group for the Public Health Alliance for Genomic Epidemiology. On behalf of myself and all of my colleagues, I'd like to echo Finn's welcome to you all to our joint PHAGE, CLIMB-BIG-DATA, JPIAMR, AMR bioinformatics workshop. So Finn, as well as myself, Andrew Page, who's one of the hackathon workshop organizers, as well as Inez Mendez and Mike Feldgarden, who will be presenting later on today, we are all members of an international organization called PHAGE, or the Public Health Alliance for Genomic Epidemiology. And PHAGE is a global coalition that is actively working to establish consensus standards, to document and share best practices, to improve the availability of critical bioinformatics tools and resources, and to advocate for greater openness, interoperability, accessibility, and reproducibility in public health microbial bioinformatics. And we tackled this work from a number of different perspectives via different work groups. And Finn, Andrew, and as Mike and I are all members of the Data Structures Work Group, which is, obviously the best one. And in the Data Structures Work Group, one of our top priorities is the development, promotion, and implementation of data standards in public health settings to help increase interoperability, reproducibility, and auditability. So we have a number of different projects on the go, one of which is very relevant to this workshop. One of the most common activities in public health pathogen genomic analyses is the detection of genes and mutations that correlate with different phenotypes. Now, there are a number of different tools that can be used for answering the same kinds of questions. And those tools can vary in their scope of function, as well as the data structures used to encode their inputs and their outputs. And that variability creates difficulties in interpreting and communicating about the results used for decision making. So because of this, PHAGE, particularly the Data Structures Work Group, have developed a specification that can standardize the way gene and mutation results are expressed by different tools. Our first application of the specification was for the detection of antimicrobial resistance, which is a massive problem, I'm sure, as you all know, around the world. We've also created some tooling in the form of different parsers, as well as interactive reports to better facilitate comparisons and data sharing. That was the really, really short version, and Inez will tell you lots more about this later on in the workshop. We've also created a contextual data or metadata specification for SARS-CoV-2 genomic surveillance to better enable data harmonization, integration, and data sharing. So whether you're future-proofing your own data for reuse down the road, or if you're sharing with trusted partners or with public repositories, we hope that it'll help to better streamline analyses and processes. We've also created some tools and resources for that spec, for example, a data collection template, as well as SOPs for data curation and data stewardship, as well as protocols for submission to public repositories. And our tools and standards are being put into practice all around the world in different pilot projects, sequencing initiatives, and databases. So for example, parts of our SARS-CoV-2 spec are being implemented at NCBI, and our AMR tools and standards are being trialed in PulseNet Latin America and the Caribbean, as well as RELAVRA, which is a surveillance program by the WHO's Pan American Health Organization. And we're really excited to be able to work with folks in real world settings, because the more standards and tools can be implemented in the field and tested, the more fit for purpose they can become. So that's it for me. If you'd like to try out any of our standards and tools, you can find them at our GitHub site. If you'd like to know more about our activities, you can check out our webpage. And if you're a bioinformatician or a software developer, or you're involved in public health and maybe are interested in joining, please do get in contact with us, because we're always looking for enthusiastic and capable members. So thanks very much. Enjoy the rest of the workshop. And I'll now hand things over to Team JPIAMR.
Thank you so much, Hannah. I am just going to share my screen and hopefully get it right. And hopefully you can see my screen and everything is good. So yeah, I would also like to echo a massive welcome to everybody. Really excited to see so many people here this afternoon, especially on a Friday afternoon. So I'm Carolyn Johnson. I'm a program manager for the MRC, and I'm actually here today to represent JPIAMR. And yeah, I'd really like to thank you for taking part in this event. And I'm just going to give you a super quick bit of background about the JPIAMR before we get started on this. So JPIAMR is an alliance of international funders that was created to coordinate the way we fund AMR research. It was made in 2011 as a European initiative, which was supposed to bring together a panel of different funders. And it now includes members from 5 different continents and 28 member states. So what did the JPIAMR do? Well, they hold some transnational funding calls for AMR, both research and networking. And the most recent call was for research and transmission of AMR. And we should have an outcome for that at the end of the year. JPIAMR also run workshops and networking events, and that's why we have such a massive interest in this one. So one of the main aims of the JPIAMR was to create a more joined up approach for organizations funding AMR research. And to do that, they produced this amazing strategic research and innovation agenda. And the SRA outlines 6 sort of key priority topics within the AMR field. So therapeutics, diagnostics, surveillance, transmission, environment, and interventions. And then each topic has a defined set of objectives. And this SRA has recently been broadened out to include resistance to antifungal therapeutics too. And I guess one of the most relevant points to for this event is that the SRA does really sort of underpin the need for developments incorporating personalized medicine and artificial intelligence to tackle AMR. So just to put some really quick numbers onto JPIAMR, the collaboration has invested more than 100 million euros in research into new therapeutics, stewardship and surveillance, as well as studies on controlling the spread of antibiotic resistance. And they've funded 117 projects and 38 networks across 71 different countries so far. And this includes 25 projects with involvement from low and middle income countries. So just a quick look at some of the different types of funding offered by JPIAMR. Both research projects and networks have been funded, and to date, the majority of funding has been invested in transmission and surveillance. So diagnostics and environment are lagging a little bit behind the curve, and these are probably where funding will be coming for next. And finally, I'd just like to say thank you so much for taking the time to take part in this workshop. The team running the event is brilliant, and I'd like to say a huge thank you to CLIMB-BIG-DATA and Phages for doing all the hard work to get this off the ground. And yeah, I'm sure you'll learn some amazing things. And I guess now I get to hand over to Team CLIMB.
Don't know if Mark or Andrew want to take the lead on introducing. Oh, there we go. You're in the process of sharing the screen.
So yeah, my name is Mark Pallen. I'm just going to give you a couple of minutes on CLIMB-BIG-DATA, which is a project that I'm the director of. This is basically a successor to a very successful project called MRC CLIMB, or Cloud Infrastructure for Microbial Bioinformatics, that was funded by the UK's Medical Research Council for a number of years. I'm not going to go through all these points here, but you can see the fact we did make a decisive influence in the UK microbiology support over those years. If there's nothing interesting to watch on the television this evening, there's a link there to a movie that where we summarised our achievements during those 7 years of funding. However, the funding for CLIMB came to an end in 2019, and we submitted a new proposal to get additional funding, and we were told that we must then move towards becoming self-sustainable, where we charge users rather than provide stuff for free. But we won a 5-year, £2 million MRC partnership grant, which funds this new project called CLIMB-BIG-DATA. Unfortunately, the project began just as the COVID pandemic kicked into gear. And so we had a bit of a rocky start. But one of the things that we did actually manage to do with the infrastructure we already had was support the UK's and the world's efforts against the COVID pandemic. This very busy slide here just summarises all the kinds of things that we're looking to do with the funding we've got. Community engagement in things like this, training, running workshops and hackathons and so forth. We're investing in our infrastructure, keeping it up to date and adding new stuff, building bioinformatics tools and integrating them. And we're sitting on top of a very vibrant interdisciplinary team with a great track record and a great environment. Lisa Marchiretto is the one that keeps us going. She's the organizer for all of our efforts, and she's played a key role in organizing this meeting and in organizing the hackathon that took part earlier. So let me thank her in advance for her efforts here. And this dashboard here just shows you some of the things we've achieved in the first year and a half with CLIMB-BIG-DATA, despite the pandemic coming in. We did actually make a big difference there in hosting all the UK's coronavirus genome sequence data. But I'm not going to go through all of these individual points. You can see that we've been quite busy, but we've already run training workshops for beginners. We ran a training workshop on the Arctic workflow for analysing coronavirus genomes and many other things. With that, I'll shut up now. Thank you.
Perfect. Thanks, everyone. So that's the many organizations that have intersected to put this together.